your homework to start with? 45, 25. All right, 25. All right, 25 is a non-calculator. Yeah. All right, hold on. I'm going to do this one. I'll go back to 19 because I've already started wrapping my brain around this. Okay, I'll show you. All right, I'm finding the limit as x goes to infinity and negative infinity here, right? First thing that I see is I'm going to start some manipulation on this right away. And what I noticed is whenever I split this up, my x cubes are going to go away. Okay, so cosine x over x cubed minus 2x cubed over x cubed. What'd y'all do?
Just cross out the cosine x. You're going to get the wrong answer. And then you get negative 2x3 over x3. That's 2 over 1. So negative 1, negative 2. That's called true.
Okay, well, you can do that. Did y'all hear what they did? I would have gone about an algebraic approach here because that's how my brain works. That's what I would do. Well, you subbed in right away, is what you did, is what you're saying. Because it's going between negative 1 and 1, and you're within friends. That works.
What? Somehow the other one says it's negative 2, but if you put negative infinity, it's different.
Okay, no, it's not different because negative 2 times negative infinity cubed over negative infinity cubed, I've got 1, 2, 3 negatives, which would end me with a negative. $19, is that what you said?
Yeah. Just for putting it in my calculator.
All right, so cosecant, is 1 over sine. That's inverse and it's different. That's probably why. Yeah. Yeah. So cosecant is 1 over sine, and that is not the same as inverse sine. It's not. Inverse sine is switching x and y. It has a restricted domain. It's just a little piece of a graph. It does like this. It's just a little, yeah. Good.
Wait, which one is
31.
What was that?
That was 19. Or you can do cosine over sine. 1 divided by tangent or cosine over sine for 31. Okay, what's it say? What are you approaching? Find the vertical asymptotes. So vertical asymptotes happen where the bottom is 0 and nothing cancels out, right? Where does that equal 0? So if I'm on the unit circle here, right? That's 0. If I come around, sine is 0 here, that's pi. If I keep going, what is that? 2 pi, and it's 0 again. If I keep going around, what is that? 3 pi. And in fact, every time I loop around and I make it back to here, then it's 0 again. So it's every pi. So all they're doing is they're saying vertical asymptotes are happening every time. Remember whenever we did those cofunctions and stuff, those packets of cofunctions we did for trig? And we said, we know it's happening every whole number pi, right? So we put some random variable in front, and then we said times pi. And we said where k is an integer.
But it goes to 3.
What is? Show me what you're. Okay, you're in a Zoom trig. Every dash mark is pi over 2. If you do a Zoom 7 on your calculator, it goes from negative 2 pi to 2 pi. And then everywhere there's a dash mark here, it's a half a pi.
Yeah, wait.
So it's every whole number pi. So how do I say that? How do I say every whole number pi? Well, I know it's going to be pi times some number, but this number is fluid. It can change, right? But it's got to be a whole number. The whole number. This means integers. But it's not all real numbers because it can't be a fraction or a decimal.
Any integer.
Any integer, if you want to say any integer. Say that again. The asymptote? The what? The what can be any number? Okay, so put one in. Think of an integer you don't think it could be. Negative 2. What happens at negative 2 pi? Well, if I start out right here, and I go, negative means go backwards, right? Here's pi, 2 pi. What's the sign of that? What's the sign at that green point right there? 0. Remember, that's what I'm looking for. I'm looking at every place on my unit circle that sign is 0. Sign is the y, so it has no height. The only place my circle ever has no height is right here on the x-axis. Okay, so tell me where. You don't even have to do the graph on that. You don't have to understand the graph on this one.
How would I get the answer? How do I get the answer? Because you have to get the answer by graph. I couldn't tell that that's the answer from graph.
Same here.
Like I can look at it, but then I don't know where to go after I'm on campus.
Learn what? Math?
Everything.
Mine's happening at every pi.
She makes it up what she
So, whenever I graph cosine over sine, I get a graph that looks like this.
Oh.
Or 1 over tangent, same thing. My calculator does not show asymptotes, but I can infer. Like you want it to go every pi? Like whenever you calculate something, no. But you can get it to where, yeah, no. This is what mine looks like. Remember, cotangent just looks like the flip of tangent. Keeps going forever, right? If I'm looking, asymptote. Asymptote. Yeah, or you would know where the bottom equals 0. Pi is 3.1415. Every one of these dash marks is half a pi. So it's, I'm going through half a pi,
if you look at your window, okay, it's going from negative 2 pi to 2 pi. It's telling you 2 pi to 4. And then it says every half a pi to the dash line. I can't remember. So that's why the dash line is. Dash line.
So dashboard is already one and two. So dashboard really aren't 1, 2, 3.
Oh, okay.
Is that what that means? Dashboards don't go by 1, 2, 3, 4.
It depends on what you're doing. So
What does that mean?
okay. Did you hit Zoom center with the graphics?
No.
Okay, now hit the button that says window.
Window. All right.
The window is telling you X's are going, okay, X's should be going from negative 2 pi times 3 is 6. Up to 6. Going from negative 2 pi. And then each dash mark, which is your scale, you know, should be a half a pi. Half of 3 is 1.5. So that's telling me from negative 2 pi to 2 pi, every dash mark is a half a pi.
Can I do that without?
If you want it. I love it. 6 is your standard number.
Okay, but it doesn't do the right way.
No, I think it's still color. No,
No, not the same thing done in 7. It's still the same graph, but instead of going from negative 6,
Well, what does Zoom 7 do?
what's your name? That's trig type.
I'm just gonna have to notice that.
All right, so pre-cal needs to spend some more time this year on trig.
Yes, they do.
Yes, yes.
I never understood. I never.
You're like, this is easy. Let's move on, Miss McGee. This is easy.
I can identify them and I know to do them.
I know y'all remember that conversation. I got this, Miss McGee.
I was there, you not got this. This is that. Like, go over that with them. The pie, ABC, that type of thing. That's what I can identify them. I know how to do. I know how to transform them.
I think remember we were like, oh, well, it's the example. Yep, that's facts.
Yeah, I was there too. I also like gave up for this because I didn't have to take it, so I didn't need it.
Okay, well, we'll get you there, even if not. Just stick with me. Stick with me. Yeah. Okay, do y'all understand this one before I move on from this one? Okay, so graphically,
If I see graphics like this, that I'm just like,
that's not true.
no, well, it'll work. It'll look like 90% of the time.
Oh, really?
No, it's
Then how does it work?
integer times pi.
So what?
I know it is. I know.
Somebody hand me your unit circle.
I don't have it pulled up.
No, unit circle.
You do K and then pi, and then you say what K is. K is any whole number.
But if you see this graph, that's
Or
showing you
any
any
integer.
whole.
All right, stop. Wait just a second. Look at this. I'm looking where sign is 0. Start. Where's sign 0?
At 0.
At 0. Where else? Pi, right?
Yeah.
At pi. No, at pi.
At pi.
Okay.
At 2 pi.
At 2 pi. At what? What else? Do we see why this is a oh my gosh.
I know, I understand that.
Okay, so is it the K pi that's throwing y'all? Is that what
Can
you're
you show me the
okay?
graph and how that relates to that? Like, I just don't do that.
So I can just write these.
If this is a half a pi, what is this? This is 3 pi over 2, which means this is
I get it. We need to take a picture of that. I actually get that.
Okay, so you don't even have to know that notation. You can say any integer times pi. Times pi. It's not any integer. Any integer times pi. They're not going to look now. If you're on a multiple choice question, they're going to give it to you like this. And all this means, that's right, is some variable times pi. What does that variable mean? Well, this little symbol means is a member of. And this little symbol means an integer. I wrote that. Thank you, Stella. Yes or no? Yes or no on that? Yes. Y'all are stressing me out. Okay. Okay. What else?
Oh, can you please do 55? Wait, actually, can you show me for that, the one that we literally just did? What is the behavior of f of x? Or wait, that's the asymptote, right? X equals 2, negative 2 pi.
Yes. Now to the left and right to know the behavior, you'd have to go back to this graph. So when to the left, the limit as x approaches pi over 2 from the left of f of x would be what? Coming in, not pi over 2, just pi, sorry. It's every whole. From the left. So this is pi, negative infinity. But if I approach pi from the right, what is it? So what's the limit as I approach pi? D and E. Why is it D and E? Okay. Huh? You did, see? You are learning, see? You are.
Okay, wait. So why did we choose pi?
Because that was just the first asymptote my eyes went to.
Okay, so it doesn't matter which one
Mm-mm.
you pick.
That's right. You could actually probably put k pi and define k again. Okay, what'd you say, Mac? 55? Ooh, this is a good one. It's possible. The limit as x approaches 1 of f of x. This is where, so now I'm going backwards on my limit knowledge, okay? So I need to take all this into account. The limit as x approaches 5 from the left. Now remember what this means. If the limit as x approaches 1 of f of x is 2, that's from both sides because that's a full-blown limit, right? But this one is only from the left, and it's infinity. What does this tell me is happening at 5? If it goes to infinity, what kind of asymptote? Vertical asymptote. I know from this that I have a vertical asymptote at 5. Okay? All right. What else do I have here? The limit as x approaches 5 from the right of f of x is also infinity. There's my vertical asymptote again. The limit as x approaches infinity is -1. What does that tell me? Horizontal asymptote. The limit as x approaches 2 from the right of f of x, negative infinity. What does that tell me? Vertical asymptote. Gracious, this is going to be a crazy graph. The limit as x approaches -2 from the left of f of x is infinity. Vertical. And then the limit as x approaches negative infinity of f of x is 0. That is horizontal. Whew. Well, let's see what happens. I've got a vertical asymptote at 5. 1, 2, 3, 4, 5.
Vertical goes to the number.
Yes. But you have to, vertical have to equal infinity. All right, so I got 5. -1 is a horizontal, but it's not bounding the whole graph because look, there's 2 there, right? It's only bounding a part of the graph. So as I go to positive infinity, I've got a horizontal asymptote at -1. And as I go to negative infinity, I've got a horizontal asymptote. I need to do these at 0. Another vertical asymptote at 2. What else do I have? Is that it? Did I get everything? And -2, right? And it does. The only other thing I have right now is as x approaches 1, it's 2 from both sides. I'm thinking that that's just a defined point here, but it could be an open. I'm going to leave it open right now. See what happens. All right, so as I approach 5 from the left, it's going up. 5 from the left, going up for something. I don't know what, but it's going up. 5 from the right is also going up. I'll worry about these other ends in just a second. As I approach infinity, so as I move to the right, it's approaching -1. 2 from the right is going down. 2 from the right is going down. -2 from the left is going up. Horizontal asymptote at 0 as I come in here and do this. So now for the rest of this, I can kind of fill in what I know or what I think it's doing. No, because this one's bounding here. I mean, you can make it go all the way across, but it's just bounding the ends. So I'm going to say maybe it does something like this. I don't know. It is. Once you get the things that you know are there, fill in the rest of it. You know it's got to be a function, so it can't have... Did I miss something? There is at -1? Horizontal at -1. Yes, as long as, remember, the horizontal asymptotes are just going to bound the ends, the very ends. As long as, because I got this end bounded by this one and this end bounded by that one. This could be filled in or not. I don't know. It didn't tell me if it was continuous or not. I didn't. I just kind of felt. So I put these little arrows here so that I knew which way. So I satisfied the limit requirement, and then from there. I mean, this very well could have done something like this. Who knows? Instead of going down. It just said sketch a graph that satisfies. And as long as it satisfies what's given, you're okay. Which other one? 45? 65. Lord Jesus. $65. Yeah. Okay, so if f of x equals 1 over x, and g of x equals x, and c equals 0, it says find the limits of f, g, and f times g as x approaches c. Okay, so this one is saying what's the limit as x approaches 0 of f of x? What's the limit as x approaches 0 of g of x? And then what's the limit as x approaches 0 of f of x times g of x? It said c is 0, and in the beginning of the problem it says as x approaches c. All right, so this one's 1 over x. Reciprocal is going to Yeah, I'm going D and E here. What did they say? They did one-sided limits there. Okay, so if I do the limit, if I did the limit as x approaches 0 from the left of f of x. So this is my little reciprocal graph, right? How you know what? I would say you wouldn't. I would have done, this is exactly what I would have done in this problem. They didn't ask me to define the one-sided limits. They just said the limit as x approaches c. I know that this one is negative infinity and this one is positive infinity, which is why I know this one does not exist. They didn't ask me to justify those, so I wouldn't have just freely justified. I would simply answer the question D and E. That's what I would do there. Same with g of x. I'm not going to do both one-sided limits. I'm not sure why they did that if you weren't asked to do that. So if I'm approaching 0 on and it's just x, then it's just 0. And then the multiply together, really, if you've done this and you've done this, all you do is multiply those two things together. Or you should. But it should be, yeah, it should be. Well, here's what they did. We're not able to multiply them in this case because this one's D and E. So we need to, I would still argue that that's still a D and E because if one part of it's not defined, you're not, kind of like, just because it cancels out, there's a hole there, but it's still x, yeah, because 1 over x times x over x. So technically there's a hole at 0, but the limit's still there. That one's a little, I would, if you understand the way I went through this, D and E and 0, and then you did, but that's fine. I'm okay with that. I would have answered that as D and E. The third one. I would have gotten D and E 0, D and E.
Oh, I didn't even.
Don't worry about that. Don't worry about that yet. We're going to focus on FRQ type stuff with writing soon enough, but right now, I want you to get a grasp on limits. No. Let's take all the trouble with. Oh, okay. Let's do it midnight tonight. That's what I heard. All right, page 1, where you are looking at the graph and analyzing the limit. Y'all are okay there? Yes, no, maybe. Don't be scared to ask if you don't understand, guys.
Honestly, can you do A real quick? Is it D and E?
A? A is D and E. Very first page, number 1, part A. Both sides, people, both sides. Left side limit, right side limit. From the right it's 2, Robert, but from the left it's negative infinity, so it's D and E. I know.
Is that 3 or just our 2? I put 3.
D and E.
I put 3.
D and E.
Oh, yeah.
I really need my dot to work. That's what happens when honors kids have questions and get confused. They just rah, 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 rah. And I just keep trying to talk, and they're just steady saying how much they don't understand as I tried to explain why. It's still not gonna work.
Like, I know that's true, but I'm like, looking at the.
No, I'm not.
Wait, I don't know what you're on though. What, 1C, you said it was mean.
No, 1A.
Oh, then they told me wrong. No, it's not.
One C is 3, yes. 1C is 3.
Oh, wait, I asked you that.
I'm sorry. Okay. Yes, I swear I had an answer key for this. Okay. This point is 0, 2. This point is 2, 0, just because my thing is not accurate. This is 3, 1. This is 3, 2. And this is 3, 3. And this is 5, 0. Okay. F of 0. F of 0. D and E. It's an open dot right there. D and E, D and E, D and E. F of 2. 0. F of... It would be 2. I thought we were looking at a limit. Everybody was talking at the same time. I was going every different direction. Okay. Stacy, get together. I need to do Stacy Lane. Stacy Lane, get together. Okay, F of 3. 3. What's the limit as x comes into 0 from the left? Negative infinity. The limit as x approaches 0. D and E, because it's different from the left and the right. That's the one I thought y'all were asking me about. Limit as x approaches 3 from the right. 2. 2. As I approach 3 from the right. Limit as I approach 3. D and E. The limit as I approach negative infinity. 1. There's a horizontal asymptote there. How are we looking at the graph? Okay. Okay. Okay, let's flip over to number 3. I realize that you did not do all of these, and I did not expect you to on the first night. All right, let's see what happens. Give me one.
Okay.
J.
Yeah.
J. The limit as x approaches 0 of the fourth root of 2 cosine x minus 5. So the first thing that I'm going to do is a substitution. Then you get a negative under the radical. So I'm going to go D and E on that one because there's no way to manipulate that in any way whatsoever. Not if you can't figure it out, but yeah. This one, think about the way this looks, right? I know that I'm not going to graph anything that has an imaginary under there, right? Like if it's negative. If I put in 0 under there, I'm going to get a negative under the radical. I don't graph imaginaries, right? But just because the function is not defined at that point doesn't mean. So go over one to the left. If I plugged in like -1, right? Well, what's the cosine of -1? Well, it's still going to fluctuate. This cosine is still going to fluctuate between what and what? -1 and 1, right? Times 2. Subtract 5 is still, so it's not. So at 0 there, it's not going to be defined there. It's just going to be no. Uni.
You can't like separate that.
No. Yeah. Not necessarily. It depends on, yeah. What you gonna make cosine? What good is it gonna do you to do that though?
I don't know, but like I don't.
Still the same thing. Okay, do this. Put it on your calculator. Y equals hit 4 and then go math x root 2 cosine x minus 5. Zoom 7. Make sure you do a parenthesis. Bless you. Why would I not be able to see anything? What did we just talk about? This is all, do you agree this is always imaginary? Why is it always imaginary? It's always going to be negative under there, always. If this, the biggest it's ever going to be is this, the smallest it's ever going to be is this. Oh. Always. So if it was minus 2, yes, I'd have a point. Yeah. Because this is always going to be between. You could have actually used squeeze theorem for that.
Can you show us how to do squeeze theorem?
Yeah, but let's go through some others and then I will. Okay. No, we just did this in pre-cal yesterday. Complex fractions. I can't plug in because I'll have a 0 in the denominator, right? So let's put them together. Let's put them together. Remember whenever we did complex fractions and we did top, bottom together?
Yes, exactly.
That's what we're doing, okay? So look, just at the top here first. Just at the top. 1 over 3 plus x minus 1 over 3 minus x. I'm actually, oh please, Lord Jesus, don't let me blow y'all's minds. I'm going to make this negative 1 times x minus 3. Nope, that's still not going to work. Never mind. Never mind. I got to just give them each other. I got to give this one a 3 minus x. I got to give this one a 3 plus x. And then I'll put them over the LCD, which is 3 minus x times 3 plus x. All right, so here, no, you're actually, yes, on the bottom if you want to, but, and I'll show you why. Hold on. 3 minus x minus, I'm subtracting all of this, so minus 3 minus x over 3 minus x, 3 plus x. Yes, because it's a denominator. All right, so my LCD is 3 minus x, 3 plus x. I multiply that to the top and the bottom, whatever's missing. What is this one missing? Because you're subtracting this whole top. There you are.
Yeah, but it's a minus.
It already had a minus. I gave it a plus. This negative sign is going to distribute 100%. Robert struggled a little bit with the algebra because of his pre-algebra days. Algebra 1. Algebra 1. Oh, because I taught you pre-cal. That's right.
That's not what she said.
Pre-cal. I said pre-cal. Didn't I say pre-cal?
You said pre-cal. No, she said
I said because of your pre-algebra days. I was thinking that I taught you algebra 2, but I taught you pre-cal. Okay, negative 2x over. I don't have to really FOIL that if I don't want to. That's a difference of 2 squares. It's going to come out to be 9 minus x squared. Yeah. Now, but look what I can do. Now I've got, it's because it's a difference of 2 squares. Oh my goodness, y'all are really, No, it's okay. Y'all weren't in pre-cal with Robert, were you? It's not his fault. It's really not his fault.
I was.
no. Oh wait, it's a plus, but it's not minus negative 3. It's 3, and then you just the negative. So it's still 3.
Mac, help your boy, please.
I don't even know.
Oh my gosh.
But I know how to do that. Oh, I know how to factor it.
It's not negative 3. It's just minus 3. We should never have. See how it's 3 minus 3. You just distribute the negative. So it's not 3 minus negative. Trust me, Robert.
Which part are you confused on?
I was thinking it was 3 minus negative 3, but I guess it's 3 minus 3.
Yeah, because the negative. Yes, exactly. Because you multiply the 3 times the minus x, which is the minus 3. There you go, Robert. You got this.
All right. Now I'm fixing to multiply the 1 over x.
Where'd that come from?
That came from here. Remember we do top, bottom, and then put them together. I did. So did 1 over x.
Dividing by x. X to 1 over x.
I don't really get 9 minus x squared.
You got it.
Foil it.
No.
Whatever. Oh, yeah, never mind.
The algebra. It's always the algebra.
It's not hard to understand.
I would never do this in a question.
If you ever can't plug in, you have to do anything you can algebraically. Oh, thanks, Rob. Really not. I've just been doing this a while. No, okay, but wait. Let's look. Negative 2x over x times 9 minus x squared. I'm going to cancel the x out. There's a hole at 0. Uh-oh. Yes, Robert. That is correct. Never divide whenever you have fractions multiplied by reciprocal. So this is x over 1. So instead I multiplied by 1 over x.
Okay. I just assumed you put an imaginary 1 on top and I didn't know you flipped it.
Yeah, flip it. It's the flip.
It always gets
It always gets the flip. All right, so now I'm the limit as x approaches 0 of negative 2 over 9 minus x squared. And now I can plug in. Right?
so negative 2 over 9 minus 0. Oh. I am in awe of you.
Do not be in awe of me, please. We will get to a point and you'll go, oh my gosh, you're an idiot, Miss McGee. Because sometimes we all talk about it and we figure it out together because we'll encounter some problems that are just, we have to talk through them. It's tonight. Okay, let's finish answering questions and we'll talk about it.
You're gonna have to do all of it. Like you're gonna put L, N, S, Q,
Those are hard.
Okay, which one are we talking about being hard now?
Can you do L? I didn't know how to do L either.
Okay. Y'all are getting caught up in the y'all need to come sit in pre-cal for a day. Yeah, on this, not with.
I know how to do this, but it's whenever you add the substitution, you're trying to do it all.
All right, so ignore the limit right now, because if we plug that -6 in, it is not going to work. I'm going to have a 0 in my denominator, yes? All right, it's not D and E. I don't know, it might be, but I don't know yet. So I need to do an algebraic manipulation. This is L. I see fractions in fractions, so I am going to work to get the fractions going, okay? All right, so I'm going to work with the top first. I could take out a 2, but what's the LCD here of just the top?
Oh, it's the
X times x squared minus 12. So to force them to have the same bottom,
I thought you wrote L and then in little things 1.
oh. Okay, so to force them to have the same bottom, what does the first one need? X. Look at the LCD. It's got to look like this. What's going to make it look like that? Well, if I give it an X, it'll look like that. You do it to the bottom, you have to do it to the top. What's X divided by X? Listen, Robert, listen. What's X divided by X? 1. What's 1 multiplied by anything? Whatever, itself, right? That's why I can multiply the top and the bottom by the same thing. I'm not changing the value. Yep. What is the second fraction missing? I should also do it to the top. Robert, be very careful on this one. Look, I'm subtracting. Because that's where you messed up last time. All right, so put the tops together, because once the bottoms of fractions are the same, I can add or subtract the tops. So I have 2x times x plus 4 minus, and I'm subtracting all of this, right? So minus x squared minus 12 over the LCD. It will. I'll put it in parentheses so Robert can see. Not yet. Kill a kitten, don't kill a kitten, don't kill a kitten. Because of this minus here. So now your goal on these is to be completely factored all the time. The bottom's already completely factored. Let's make the top completely factored. And to do that, I need to expand it some before I shrink it in. 2x squared plus 8x minus x squared plus 12. It might be what you got. I'm taking it step by step here. So now I have x squared plus 8x plus 12 over x times x squared minus 12. I'm probably going to stop right here for just a minute because I could actually go ahead and sub in. Remember, the whole goal is getting it to something that I can sub into. Oh, I haven't multiplied by the reciprocal. Never mind. Shut up, Stacy. Okay. Let's keep going. Let's factor the top. Can you factor? What multiplies 12 adds to 8? 2 and 6. That's right, or 6 and 2. So I got x plus 2, x plus 6 over x times x squared minus 12. Now I'm going to multiply by the reciprocal. I keep wanting to cut that off. 1 over x plus 6. Do you see where the magic happens?
Yes.
The bottom, this whole bottom was x plus 6, so I did 1 over x plus 6. That cancels. So I got x plus 2. And remember, don't lose track of the goal here. The goal here is to get this to where I can plug in that limit value so that I can evaluate algebraically, right?
Right.
Bingo. Good job. Now put in -6. Isn't it -6? No, you're not. Limit as x goes to -6 of x plus 2 over x times x squared minus 12. Now this is just a plug and chug. -6 times 24. -4 over -1 over 36? Regular. That's right. Good. I told you.
Like, I give up after, like...
Don't give up. Don't give up, stuff.
Like, I do it, and then I'm like, this is a great time to study this, and I... Yeah, please help us review on that.
Did y'all get big C?
I did not get big C. I did not get big C. Let's see, big C. I did know.
With the absolute value or with the...
Oh, we also get Zippy's after value.
Yeah,
No, the 3 problems that I've done.
Wait. Good thing I'm not a tree. That's right. I didn't kill them. I just reaped the benefits of their death.
Okay.
Sounds like what?
Sounds like the Lorax, to be honest.
The Lorax?
Yeah. You're giving the ones where you're giving the ones.
Well, listen, I provided y'all, look, you could do it on like a Miro board or something, and then, I know. That's because y'all had a lot of questions. Please text me and remind me. All right. Laney Grace is fixing to have a heart attack about these infinities. I'm going with 0 on this one. I said I'm going with 0 on this one. Right, so it's still the square root of something really, 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 really big. But look, really what I'm doing, I mean, that's not even notable. These are exactly the same, and you're subtracting. I would do 0 for that one, yeah.
Is it a feedback?
We do 8.
It's a negative. So whatever.
Yeah.
I'm going to say that is a D and E because it's negative. Because remember what a square root graph looks like, right? You're never going to approach infinity because it's got a domain restriction on it.
How do you write the answer? Like fx equals 0?
The limit of equals 0. Now, if they defined it as f of x, you could say the limit as you go to f of x, but they don't. Yeah. Can you have a negative square root? You're never going to go towards negative with a square root. It's okay. Okay. If I don't have a calculator, which, well, I guess this is one. Yeah, if I did. I would probably do, if I plug in 1 here, first of all, is this a continuous function? In other words, are there discontinuities in this? And we'll really talk about this more next week. It's a square root, right? We know what a square root graph does. It does this, or it might do this, or it might be, but it's continuous, right? There's no holes. So if I'm defined here, then my limit should be that value, right? Because the only time the limit's not the same is if I end up with a, okay. If this, let's say this was my graph, and that's not it because this has got a reflection over y, so it's actually, but anyway, regardless, if I've got a square root graph, right, and I want to know the limit as I approach any point on that graph, as long as there's no holes, asymptotes, jumps, anything like that, then the function value and the limit are going to be the same. That's why you can plug in, right? Right. So I could just plug 1 in here. Oh, yeah. Because if it wasn't continuous like that, that wouldn't work that way. If there was a hole there or a jump discontinuity or something, or I didn't know what this graph looked like, or it was something funky, I mean, but I know what a square root graph looks like, and I know a square root graph starts at a certain point and just poof, goes off forever. So every point on here has a defined limit, and that limit is the same as the function value itself. There is no point that sits above it where it could be a hole with another point. That doesn't happen. Depends on what you're working with. So like the rationals and things, I have to do the complex fractions and I have to go through and rework them. But if it's a function I know that I recognize, remember when we did pre-cal and we did those 12 must-know functions? If it's one of those and I know what it's going to look like graph, that helps me with how I need to evaluate it. So I know that that's linear, right? A linear is continuous all the time. It's just going to be a negative slope line, so I could just plug the value in there too. But this one was a little bit confusing because it was a left side limit. So, but I was just telling you that if it's a continuous function like that, the left and the right side limits are going to be the same anyway. You can still do a plug-in situation. Okay, which one? H. We're going backwards now.
The hard one.
And then if you have time,
can we do one that has like the E in it, like A, B?
I'm assuming I can't plug in here. If I plug in 2, I get 2 squared is 4, I get square root of 9, which is 3. Okay, 3 minus 3 is 0, so that doesn't work. I can factor the time. I'm just going to start spitballing different things that I know I can do when I see, yeah, because I mean, really, I don't know which direction to go with this. I see a quadratic that's factorable, and that's an easy fix. I can do x plus 4, x. I don't know that that's getting me anywhere. What if I multiplied by the conjugate? Do y'all remember conjugates? Conjugates just change the middle sign to get rid of i's or radicals. So what if I took this and I multiplied by, I don't know if this is going to work, square root of x squared plus 5 plus x plus 1. Do it to the top too. And I'm probably not going to multiply all this out up top because I just need to get myself, I need to know that the denominator gets out of the situation that it's currently in, which is I get a 2. So let's see what happens. When you do this, when you FOIL these two together, the radical goes away, yes? I hope so too. this is going to be plus x plus 1. I'm just going to leave this chunk together because I think, actually, this is going to cancel because those are the same thing.
I would have never guessed.
I don't know. Photo math kind of tuckers out after pre-cal. I don't know who came up with it, but they didn't go above algebra 2 level pretty much. I foiled this out. Why? X squared minus x squared. No, I didn't do it top and bottom. Thank you.
I think it would work at this point.
I think so too.
I think it would work. I would never. 8? 8?
What am I approaching? 2? Bro, it still doesn't work. 2, not 2, look. Which letter was this? 2 squared is 4. 4 plus, yeah, 3, no. It's fixing to be there. I see it already. Yeah. Yeah. If I take out a negative 2, I get x minus 2.
I would have never done that. I don't even know what you just did. Like, you took the conjugate, okay. I just have to get this wrong. Like, I'll just get it wrong. D&E, I'm a bit.
Okay, so look.
I don't know what's going on.
I wanted to make sure it worked. Okay, let me go back. All right, let me go back. When you see radicals, okay, that you are trying to eliminate something, think conjugate. Conjugate just means change the one sign in the middle and multiply, okay? 9 times out of 10, it's going to get rid of your radical. Then back up and punt. Yeah, it did. Look at the bottom. I was trying to get rid of it in the bottom.
But how do you even do that?
Okay, hold on.
Oh, but now you can.
Yes, you absolutely can. Look. I'm going to go back. All right. Look. Okay, I'm going to show you. When you FOIL this out, okay, the 2 square roots will cancel each other out. That's how I get x squared plus 5.
But you're not dividing.
I am. I'm just working in the denominator of the fraction right now. Okay? When I multiply here times x plus 1, and then this is the complete opposite, right? So, actually not there, sorry, here. This is negative x plus 1, positive x plus 1, but these two are exactly the same, so they cancel each other out. It'd be a 1 minus and 1 plus, and so they cancel each other out. So really, when you have conjugates, all you have to do is multiply the first 2 and the last 2, because the middles are always going to cancel out with conjugates. That's the point of them. Okay, so it leaves me with x squared plus 5 minus x plus 1 squared. I FOILed this out to get this. And then I combine like terms. Yes. Yes. Send it to who? Okay, so I still haven't gotten to the answer part of it because I got to plug in, right? So I haven't plugged either. I just manipulated. I've got this equation, but it looks terrible, but I can plug into this now because I no longer have, it doesn't matter because the bottom won't go to 0. So I don't know what you get, but something. 6 times 6, if I put it in here, this would be 3. Yes. 9, 10, 12, -6. No. 3, 5, 6, 36, -18.
I got 7. I did not know that's exactly what I got. Oh, 6 times 6.
All right, so look, take your eyeballs over to capital F at the bottom of that page. I would do the same thing with conjugates on that one. I would multiply that by the square root of x plus 1, top and bottom, and cross my fingers and hope that that canceled out there. I'm not worried about the top. I can plug whatever I want into the top. I'm just worried about the bottom breaking down the way I need it. All right, we got 6 minutes. Give me another one. Flip over to the other page and give me one.
I haven't looked at the other page. Oh, number 5.
Okay, 5 is a good one, and let me show you why. This is one that they love to give on a multiple choice question, and they will throw a random variable in there, and they say, what value do you have to put to make this be bleh? So this is find the value of the parameter k to make the following limit exist and be finite. What is then the value of the limit? So this is what we call plugging the hole. Okay, and essentially what you're doing, you need, I can't plug in 5 the way it is, right? In order for the limit to exist, I need to be able to rework this where I can get that out of the bottom. If that's the case, I need an x minus 5 up top so that they cancel, right? What would have to go here to make that true? X plus 4 is what you're saying. And now, so if I multiply this out, x squared plus 4x minus 5x minus 20. So this is good, which means my middle term needs to be yes. You have to think. It's conceptual. Huh? Yeah. Look at you. All right, so I'm